Hello and welcome. In this video, we're going to be revising a super important topic. We're going to be going through incline planes for the mechanics test. This is going to be an all you need video for the mechanics incline slopes and particles on incline slopes chapter. Before I start solving, I'm gonna quickly go through with you some basic information so we are on common ground, and I'm gonna tell you some steps that you will use to solve any single question of that type as long as you go through those steps. So first of all, let's say we have this object. There is a force on the right of 10 newtons and there is a force on the left with 5 newtons. And I would ask you, what's the equivalent of these forces? What's the resultant force? If you tell me it's 5 newtons to the right, I tell you you are correct. And here, this is one case where we have something that is called a resultant force. Here, are the forces balanced? No, they're not balanced. So this is the first case. The second case, as you can guess, if I have a 10 newton to the right, 10 newton to the left, that means that my resultant force, or in another way, instead of resultant force, I can write it as sigma forces. And I believe you know what's this, and you saw this a lot in Newton's second law. So resultant force or sigma forces is equal to 0 because the forces are balanced. This is the second scenario, and any single Newton's laws of motion, incline, not incline, any single question that you're gonna have is gonna fall either under this or this scenario, nothing else. Please note that here we are balanced in the x direction because you need to think about the x direction alone and the y direction alone. So let's say we have some forces like this, then I have a 5 newton up and a 2 newton down. Let's say my axis is, this is the x-axis, this is the y-axis. If I say sigma f equals 0, this doesn't mean anything. I need to specify sigma f or resultant force in which axis. So sigma f in the x direction is equal to 0. So this falls under the second scenario. However, sigma f in the y direction is not equal to 0 because if I take a look at my y-axis, I can see that the forces are not balanced, but it's equal to 3 newtons upwards. Okay, so this falls under the first scenario. So I can have the same object having both scenarios. It depends on am I looking at x or am I looking at y. If you understand this, you will solve any question of inclines or non-incline, any balance forces, resultants. This is super important. So to summarize, we have only two scenarios. When scenario number 1, when we have sigma f equals ma, it's no longer equal 0. Okay, forces are not balanced. This is when we have a resultant force. And the second option, when sigma f equals 0, when the forces are balanced. And we have another name for scenario number 2, we call it in equilibrium. Okay, why is this important? It's super important because when the forces are balanced, sigma f equals ma. So if sigma f is 0, then m times a, m cannot be 0, so a has to be 0. So whenever the forces are balanced, I have something that's super important. Acceleration is equal to 0. Okay? And if I ask you, when is acceleration 0? Can you give me an example? Some of you told me if the object is at rest, then 100% acceleration is 0. There is another scenario where students sometimes forget, is when the object is moving with constant velocity. Why constant velocity? Because from the definition of acceleration, acceleration is what on the basic level? It's just change in velocity over time. If I'm in a case where my velocity is constant, my velocity is constant at any value, let's say 10 meters per second. Is there going to be any change in velocity? No, change means that the velocity is changing. If it's constant, then delta v is 0. So 0 over t is going to equal 0. So at the end of the day, I'm going to have an acceleration of 0. So turns back to this position. Sorry, this scenario. Okay. The second thing, or the first scenario, when the forces are unbalanced in one of the two directions, or maybe both, when the forces are unbalanced, here I have an actual acceleration value, and I'm going to show you how to solve. But from now on, the questions that I'm going to attempt, first thing I'm going to ask you is you need to determine x or y. Choose. Are we looking at x? Okay, if we're looking at x, tell me, is x falling under scenario number 1, where we have a resultant force and we have acceleration, or is it falling under scenario 2, where it's in equilibrium? This is super important, and this is what we are going to solve from now on. Okay, let's take a look at some questions. So, to solve the questions, I told you I'm going to give you some steps. Okay, the first step is to always, if you have an incline, to always choose an axis. And I'm going to show you what does this mean. Okay, the second step is to draw a free body diagram according to your axis and resolving according to the axis. The third step is to determine, this is the step I told you about, to determine are we scenario number 1 or scenario number 2, non-equilibrium or equilibrium. That's it. And when you determine, you can write the equations and solve for the unknowns. Let's apply these steps to the questions that we have. Let's start by reading the first question. The question says, a block of mass 12 kilograms is placed on a plane which is inclined at an angle of 24 degrees to the horizontal. A light string. What does light mean? Light means that if we have two objects connected to the string, the tensions on both objects are going to be the same. So the tension throughout the string is the same. Okay, these are keywords that are super important in mechanics. So a light string making an angle of 36 degrees above a line of greatest slope is attached to the block. The tension in the string is 65, so this tension is 65. The coefficient of friction between the block and the plane is mu. So basically, I know that this plane is not smooth, it's rough. How do I know? Because there is coefficient of friction, or there is friction. The block is in limiting equilibrium and is on the point of sliding up the plane. Again, limiting equilibrium is an important keyword. You need to understand very well how to deal with it. And let me stop you for 1 second and show you something. I have designed this course for mechanics. It's basically a whole year course designed to replace expensive tuitions. It has everything you need for mechanics. If you take a look, this is the course designed by me. Actually, you will find the same exact if we open any video, the same exact whiteboard I'm using with the same mouse, and it's basically me. This course is amazing because it has everything you need for mechanics at Excel and Cambridge. It has every single chapter with every single topic discussed, and then solving examples. Let's say statics here, we have the explanation and then solving, lots and lots and lots of solving. Same thing for momentum and then solving past paper questions. Same thing for moments and energy, every single thing. And then at the end, you will have a full-on past paper solving section. And this is where I want you to take a look. Section 10 is a summaries and keyword section. It's amazing. It summarizes all the keywords that you need to know, like limiting equilibrium, light string, inextensible. You have it all in your hands. It's super useful. And I'm gonna do something for you. Here is a discount code that you can put. You can copy this code and put it while checking out. Is gonna give you a huge discount. Anyways, check it out. I'm gonna leave a link to it on the top right hand corner. So going back to the question, we read this word limiting equilibrium. What does limiting equilibrium means? It means that we are in equilibrium. We are in scenario number 2. There is no acceleration. However, the word limiting tells me that it's literally on the point of breaking this equilibrium, on the point of accelerating. So the forces are just enough to balance each other. Any slight increase is going to mean that our friction is no longer going to be able to hold this box or object from sliding up. So it tells me, in other words, that the friction is reached its maximum value. It cannot go above that. Okay, and this has a special equation called mu times r. I'm gonna tell you what's mu. Mu is coefficient of friction, r is the normal, and we're gonna get to that. Okay, so over here The question wants me to find mu. It's a 6 marker. This is a Cambridge question. So for Cambridge, you take 10 meter per second squared as g. Anyways, what's the first step? Is always choose your axis. What do I mean by that? In incline plane, without thinking, your axis is no longer going to be the normal horizontal x and vertical y axis. No, because this is going to make it a lot... It's solvable, but it's going to make it a lot more complicated to solve. Another axis that you can choose, which is the better and the one that you should choose always, is x. Axis is going to be the direction of the slope. This is going to be my x-axis. And the direction perpendicular to the slope is going to be my y-axis. So this is the axis that I'm going to use. So let me write it over here, that this is going to be my x-axis. This is going to be my y-axis. Now I'm done with the first step. Second step is to draw a free body diagram. Let's try and draw on this diagram over here. Or actually, let me redraw it. Let me redraw it over here. I prefer that to have enough space. So very quickly, this is 24 degrees. This is my object. I have this force 65 newtons and it has an angle of 36 degrees to the plane. Okay, now the second step is to draw a free body diagram. Let's draw a free body diagram. Free body diagram is basically all the forces that are acting on this object. Okay, so what forces are acting on the object? I always like to start with the force that's always there, which is going to be the weight. Weight is going to be the mass, which is 12 kilograms, times the acceleration of gravity, g. Okay, another force is always there, which is the normal force or the reaction force. Okay, I call it R, and it's always perpendicular to your plane. If your plane is horizontal, then the normal force is going to be vertical. If your plane is inclined, then the normal force is going to be perpendicular to the slope. So this is R. What else do I have? It says that the object is on the point of sliding up the plane. So if the motion is tending to go up, okay, how do you think friction is going to act? Friction always opposes motion, so if I'm trying to go up, friction is going to try to put me back down. This is going to be the friction force, and it's going to have an equation of mu times R. Now, is there any other forces? I have the 65, blah, blah, blah. Everything's done. Am I done? No. Free body diagram, you need to resolve your forces according to your axis. I said this. What does this mean? Ideally, we want every single force over here to be fully aligned with X or fully aligned with Y. I don't want a force to be in between them. So let's take one by one. Let's take the resultant force. Is it aligned with X or Y? You tell me yes, it looks like it's fully in the Y direction. What about mu R? Mu R, yes, it's fully in the X direction because the axes go up and down in opposite directions. But let's take a look at the weight. Weight is not fully in X nor fully in Y. So what do I need to do? If weight is causing me problems, then I will need to resolve it. I will need to, in other words, force it to align with those two directions. So instead of using the weight, I'm gonna split the weight into two components. We call them components that are aligned with our axis. So the first component is gonna be aligned with the Y. Okay, and the second component is going to be aligned with the X. So in other words, I split this 12G because it was causing me problems into two smaller forces that are not going to cause me problems, that are going to be properly aligned. Okay, so I'm not going to go through this. This is 24, so this is also going to be 24 for the time of the video. So how much is going to be the value of these two components that I chose? So I always do this. I always start from the force that I'm resolving and then see if I'm going to the direction closing on my angle, which is 24, then it's going to be cosine. So 12G cosine 24. Then again, I'm going to start up my force and then see if I'm moving to the direction away from my angle, it's sine. So this component is going to be 12G sine 24. Okay, now we finished R, mu R, 12. Let's take a look at this 65. Is it aligned with one of the two axes? No. So again, we'll have to resolve it just like we did for the weight. So let's resolve it in two components. One component aligned with the X and one component, let me erase this so I have space, and one component aligned with the y. Okay, if the 65 is pulling in this direction, it doesn't make sense for the x to be in that direction and the y to be in that direction. This is logical. Okay, so again, I'm gonna start on my force and see, am I going closing on my angle? Closing, so is it sine or cosine? If you said cosine, you're correct. So 65 cosine the angle, and here I'm moving away from my angle, so it's 65 sine 36. Okay, that's basically the free body diagram. What I need to do is determine, do I have any acceleration in the y or in the x? This is super important. So this is the third step. Am I in scenario number 1 or scenario number 2? It tells me that the object is in equilibrium, so definitely in both directions it's scenario number 2, I believe, which is equilibrium. So we are in equilibrium over here, meaning that all the forces are balanced and the object is not accelerating. So let's start by resolving, okay, in one direction. I always advise you to start resolving in the y direction. So scenario 1 or scenario 2 determines, is sigma Fy equals ma or 0. Since it's in equilibrium, so sigma Fy is going to be 0. And by the way, in inclines, always the y direction is never going to have any acceleration. If you're going to have any acceleration, it's going to be up or down the slope. So always sigma Fy is going to be 0. So sigma Fy is going to equals 0. In other words, tells me that all the forces in the y direction balanced each other. Remember the ball when we said it was 10 Newton like this and then 10 Newton there. So the forces balance. So the forces in one direction equal the forces in the other direction. So R plus 65, the total forces upwards, is going to equal the force downwards. So basically, this is my equation. So R plus 65 sine 36 is going to equal the downward forces, which is 12g cosine 24. And this is my first equation. What I can do is I can find R. R is going to equal 12g cosine 24 minus 65 sine 36. Okay, now I'm done with the y. Let's now look at the x. X here, you need to be careful. It could either be sigma f equals ma or sigma f equals 0. Here, since we're in equilibrium, so sigma f equals 0. So forces in opposite directions balance. So this force, which is up the plane, is going to balance the combination of these two forces. So I'm going to have 65 cosine 36 equals, or balancing, the combination of those two forces, which is 12g sine 24 plus mu r. So plus, I don't know what's mu, so I'm going to leave it as mu. And r. R I already found from here, right? So I can just basically copy this and paste it. Oh my god. Okay, let's just rewrite it. So mu times r, which is 12g. So instead of r, I'm just going to write 12g cosine 24 minus 65 sine 36. And from here, I can find my mu, where I can move this to the other side. So 65 cosine 36 minus 12g sine 24 is going to equal this. So I'm going to divide both sides by basically this value, which is 12g cosine 24 minus 65 sine 36. And when I do that, I'm going to find a value of mu of, remember to replace g with the correct value. For Cambridge is 10, at Excel is 9.8. When you solve this, you're going to find mu as 0.0529, and this is the correct answer from the mark scheme. So this is basically how to solve this first question. That's a 6 marker. These questions are very repeated. The ideas are always the same. So it's very useful for you to understand. Okay, so now let's just delete some things so it's not laggy. Now we're done with this question. let's move on to the next question. So over here, let's start by reading the question. A particle of mass 2.5 kilograms is held in equilibrium. So again, straight away, it told me that this is going to be in equilibrium. So it's scenario number 2 where acceleration is 0. It looks like the ball is not moving. So on a rough plane, okay, so there is friction. Inclined at 20 degrees to the horizontal by a force of magnitude T. I don't know what's the magnitude. Angle is 60 with the line of greatest slope of the plane. The coefficient friction is given. It tells me find the greatest and least possible values of T. Okay, this is interesting. What you should think about is this. So this ball is being held by the force T. So we have two options. Either the ball is on the point of moving upwards because T is very high. Imagine you're pulling a ball in this direction and it's about to move up. It means that your T is very large, right? T is going to be a very large value. Or the second option is T is just barely holding this object and it's tending to slide down. If T decreased a little bit, it's not going to be enough and the ball is going to slide down, right? So this is what it means by the greatest and least possible values of T. So first, let's start by doing our 3 steps again. So the first step is the axes, free body diagram, and then scenario 1 or 2. So first of all, axes, again, the x-axis is going to be parallel to the slope and the y-axis is going to be perpendicular to the slope. Now let's draw a free body diagram. Let me redraw everything so I can have space. So this is 20 degrees. This is the ball over here. I have tension force 65. Is it 65? No, 60. 60 degrees. This is tension. What else? Okay, let's start by drawing all the forces. So I'm gonna have the weight directly down. It's gonna be 2.5 G, okay? And I'm going to have obviously the normal force or the reaction force, R, and I'm gonna have friction. Now, let's first start by finding the greatest value of T. So greatest. So greatest value of T means that T is very large, and if it increased a little bit, the object is no longer going to be in equilibrium and is going to start moving up the plane. So greatest possible value of T is a value that's going to put my system in limiting equilibrium, where the system is going to tend to travel upwards. If I'm tending to travel upwards or on the point of sliding upwards, okay, my friction is going to be in the opposite direction. So friction here is going to be in this direction and it's going to be maximum. It's going to be mu r, right? Now I drew all the forces. Let's do the resolving part. So again, the weight, I'm going to resolve it into 2 components. This is 20. This is going to be 2.5 G cosine 20. And I'm going to have a component this direction, 2.5 G. I'm moving away from my angle, so it's sine 20. What else needs resolving? Mu r doesn't, T needs. So I'm going to have 2 components for T. I'm going to have one this direction. T, I'm closing on my angle, so it's cosine 60. And over here, I'm going to have a component in the y direction moving away from my angle, so it's T sine 60. And I know that this is scenario number 2, where sigma f of x equals 0 and sigma f of y equals 0. Again, as I recommend, always start with sigma fy equals 0. Is going to help you a lot. So sigma fy equals 0 means that the forces in the y direction are balanced. So the 2 upward forces are equal this downward force. So let's write that. So we're going to have r plus t sine 60 equals the downward force, which is 2.5 g cosine 20. Over here, I can move this t sine 60 to the other side. It becomes minus t sine 60. And over here, I'm just going to have r. So this is going to be the first equation. Now let's do sigma f of x equals 0. Again, if they're equal 0, this force up the plane is going to balance these 2 forces down the plane. So I'm going to have t cosine 60 equal mu times r. Instead of r, 2.5 g cosine 20 minus t sine 60. That is mu r. And then plus 2.5 g sine 20. Now from here I can solve for the value of t, knowing that mu was given. How much was mu? 0.3. So I can replace this mu with 0.3. Let me multiply. So I'm gonna have t cosine 60, and then I'm going to multiply this 0.3 to this negative t sine 30 is going to be negative t times 0.3 times sine 60. Moving it to the left is going to be plus 0.3 t sine 60 equals, I'm going to have this 0.3 times 2.5 g cosine 20. So 0.3 times 2.5 is basically 0.75 g cosine 20. And then I have this term over here plus 2.5 g sine 20. I can take a t out common from here. So I'm going to take t common from those two terms, and I'm going to divide by cosine 60 plus 0.3 sine 60 on both sides. And this is going to give me the value of t. If I put it on the calculator, it's going to give me a greatest value of t of, answer is t equals 20.5 newtons. So this is going to be the first part of the question where it wants the greatest value. If you can work out what's going to be the least value of t, the thing is, if we can copy this, I'm not sure if we can copy it. Yeah. If we can copy it over here. Now, if we're thinking about the least value of t, let's erase some, no, this is not gonna be it. Let's think about what's gonna happen to friction over here. We're gonna have the same exact thing. However, friction, if this is the least value of t, it means that the t is barely holding this object, and the object is tending to slide down. So instead of friction in pointing downwards like last time, friction is going to tend to be upwards this time. So mu r is upwards. So sigma fy, we're going to have the same exact equation. However, in sigma fx equals 0, I'm going to have the forces up balance the forces down. So forces up now is t cosine 60 plus mu r. So t cosine 60 plus 0.3, which is mu, times r, which was 2.5 g cosine 20 minus t sine 60. So now the t cosine 60 plus mu r are going to be balanced by the 2.5 g sine 20. And now I can solve this equation for t again. So I'm going to have a t out common of, I'm going to have this cosine 60. And then this is going to be minus 0.3 sine 60. And then equal 2.5 g sine 20. I'm doing this fast because I want to cover most time. You can do it. I want to cover a lot. So you can make sure of it in your own time. So I'm going to move this 0.3 times 2.5. So it's minus 0.75 g sine 20. Divide both sides by this. You're going to have a t value of, oh yeah, this, the 0.3 times 2.5 is 0.75. This is cosine, not sine. This over here is cosine because this is cosine. So this is cosine 20. So the answer is going to be, yeah, so you'll have a t value of 6.25 or 6.26 newtons. This is the least value of t. And this over here, the 20, which one? We solved it, I don't know where I wrote it, but I believe I wrote it, right? So t here was 20.5 newton. This is the greatest value of t, and this is going to be the smallest value of t. Now, let's take a look at another example. So let's start by reading the question. It says a particle P of mass 0.3 kilogram rests on a rough plane. The word rough tells me there's friction inclined at an angle theta to the horizontal, where sine theta is 7 over 25. Okay, this is interesting. What you can do is you can say, okay, theta is going to be sine inverse of 7 over 25. You get the value of theta. But what I like to do when I have this is I like to draw a small right angle triangle and call this angle theta. And this is 90 degrees. Sine is opposite over hypotenuse. So opposite 7, hypotenuse is 25. Doing Pythagoras to get the other side is going to give me 24. So I'm going to have this as 24. So I'm going to have sine theta equals 7 over 25. And cosine theta equals adjacent, which is going to be 24 over 25. So whenever I have a sine theta in my equation, I replace it with this. Whenever I have a cosine theta, I'll replace it with this. Okay. So a horizontal force of magnitude 4n acting in the vertical plane containing a line of greatest slope is applied to P. The particle is on the point of sliding up. Again, on the point of sliding up tells you that it's in equilibrium. However, limiting equilibrium, so friction is maximum. Show that the coefficient of friction is this. Again, our steps. First step is the axes. We already know that the axis is going to be this is the x-axis. This is the y-axis. Second step is the free body diagram. So super quickly, we're going to have this as theta. This is the particle P. And let's start by drawing the weight. Weight is going to be down, so 0.3 g. I'm going to have the r. Notice I always start with the weight. Actually, let's move this a little bit down. Yeah. So I have my normal force over here, which I'm going to call, it's sometimes called normal, reaction, they're all the same thing, so I'm just going to call it R. And I have my 4 newtons over here. This is the 4 Newton force, and it tells me that it's on the point of sliding up, so friction is going to be down the plane and it's going to have a value of mu r. Now let's resolve the forces that needs resolving. Always start with the weight. So weight is going to have a component in this direction. This is going to be theta, so this is 0.3 g cosine theta, and a weight component this direction is going to be 0.3 g sine theta. Again, what else needs resolving? The 4 Newton is not aligned with the y or x, so I need to resolve it. So if this is theta, then this angle is also theta, because this is parallel to this. They're alternate interior angles. So I'm going to have 2 components of this 4 Newton, one over here, which is 4. Now I'm starting at the 4, I'm moving away from my theta, so it's going to be 4 sine theta. I'm going to have a component in this direction. I'm starting here and I'm going in the direction closing on my angle, so it's 4 cosine theta, and then acceleration is 0. So again, let's start by doing sigma Fy equals 0. So I'm going to have the reaction force upwards is going to equal the 2 downward forces, so R equals 4. Instead of sine theta, I'm going to put in 7 over 25 plus 0.3 g. Instead of cosine theta, it's going to be 24 over 25. This is the first equation. Let's continue on the left over here. So sigma f of x is also equal to 0. So forces upwards, like the 4 cosine, so 4 times 24 over 25. This is the only force upwards. Yes, so it's going to equal the forces downwards. It's going to equal the 0.3 g times sine theta plus mu times r, which is 4 times 7 over 25. 4 times 7 is basically 28. So basically 20. This is 28 over 25. Plus 0.3 times 10 is 3. 3 times 24 is 72. So this is 72 over 25. And from here, I can find my mu. This is going to be 4 times 24 over 25 minus 0.3 times 3 is times 10 is basically 3 times 7 over 25 is going to equal to this. So I'm going to divide both sides by 28 over 25 plus 72 over 25. This is going to equal mu, which is going to be equal to, if you put this whole thing on the calculator, it's going to give you a mu value of 3 over 4. And this is the value that we were required to show over here. Now, let's take a look at the first example for today where we actually have acceleration. So now the force acting horizontally, this 4 Newton, which was horizontal, is now replaced with a 4 Newton acting up the plane. Whenever you have something changed, it's advisable, it's always better to redraw everything. So this is theta. I'm going to have this free body diagram. So this is 0.3 g. I'm going to have the normal, which is r. And the 4 Newton is now acting like this up the plane. It was no longer horizontal. Okay. And it tells you that there is acceleration of p. So this particle is now accelerating and it's going to accelerate up the plane, right? So if it's accelerating up the plane, the friction is going to be down the plane, mu r. Now, anything else? No, let's resolve our weight. We're going to have a component like this, 0.3 g cosine 20, and over here, 0.3 g sine 20. So again, let's start with the sigma Fy. Sigma Fy equals 0. But sir, there is acceleration. There is acceleration, yes. However, the acceleration is in the x direction. By the way, you're required to draw the acceleration when you have one, and it's drawn by a line with 2 arrows instead of 1 arrow like forces. This is how you differentiate between acceleration and force. So sigma Fy equals 0. Yes, it is equal 0. But how? There is acceleration. Yes, because this acceleration is fully in the x-axis. There is no acceleration in the y-axis. So the forces on the y-axis are balanced. So r upward force is going to equal the downward force, which is 0.3 g. Cosine is basically 24 over 25. This is r. Now let's do sigma f of x. What's sigma f of x? Is it equal 0 like all the questions we've been doing? No. Now sigma f of x is equal to ma. So now it's a little bit more steps here. When you see that you have sigma f of x equals ma, then it's no longer forces are balanced. No. Forces are not balanced. So you have to write the sum of forces, putting some forces are going to be positive, some forces are going to be negative. How do I determine? I need to choose a positive direction. Which direction do I choose positive? Is it going up the plane or down the plane? It doesn't go like that. It goes with, you should always take the positive direction as the direction of acceleration. If acceleration is up, like this case, I'm going to take up the plane as positive. If acceleration was somehow down, I'm going to take down the plane as positive. You always copy the direction of acceleration. This is what you should do. So let's do that. So sigma f of x, any force that's in the upward direction is going to be positive, like the 4, let's say. And then this mu r is down, so it's going to be minus mu, which was 3 over 4, times r, which is 0.3 g times 24 over 25. And then this 0.3 g sine 20 is down, so it's also going to be minus 0.3 g sine 20. This is the sigma f of x. We don't have any forces in the x direction. We finished all of them. This is going to equal to m. M was 0.3 kilograms and times a. So if I want to find a, I divide both sides by 0.3. If I put this in the calculator, a is going to be a value of, you can replace this sine 20 with 7 over 25. You're going to find a having an answer of 10 over 3 meter per second squared. That is the value of a. And now you got your 3 marks. Now, question C says, starting with P at rest, the force 4 Newton parallel to the plane acts for 3 seconds and then is removed. Find the total distance traveled until P comes to instantaneous rest. So this 4 Newton is going to act for only 3 seconds. Okay, so it means that as long as this 4 Newton is acting, our acceleration is 10 over 3 meters per second. So let's see for those 3 seconds, this is now a little bit of kinematics. For those 3 seconds, how much did the object move under this acceleration? So we have the acceleration as 10 over 3 meter per second squared. The time is equal to 3 seconds. The initial velocity is equal to 0. And I want the displacement. So I didn't mention v, so I'm going to use s equals ut plus half at squared. So s equals u 0, so everything is 0, plus half times 10 over 3 times 3 squared. So this is going to be 0.5 times 10 times 3, so it's basically 15 meters. Okay, now this is the first 3 seconds. Okay, something interesting is happening. After 3 seconds, the force is removed. So what happens now to the particle? The particle is moving with some acceleration and it reached a final velocity. And after 3 seconds, it reached some final velocity that we don't know. Right? So it's gonna continue with this velocity a little bit before it stops, right? Nothing stops instantaneously. We all know that. So it's smart for us to try and find what is this v. I can find it from the equation v equals u plus at. So v equals 0 plus 10 over 3 times 3. So v is going to equal 10 meter per second. Now, let's think about the changes that happened when this force is removed. Again, I told you, whenever a force is removed, a force is added, anything changes, you need to redraw your whole thing. So now, the forces acting on the object is going to be the weight, 0.3 g, okay, the normal. And since the object is moving upwards, however, the force Newton is removed. It's moving upwards because it had some velocity. It was moving with 10 meters per second. When the force is removed, it's not going to magically stop. It's going to continue a little bit, just like when you throw a football in the field. It's gonna, you kick it one time, you don't keep on kicking it. You apply the force for 1 second, but it doesn't stop when your foot leaves the ball. It continues a little bit until it stops because it has some velocity. So the ball is moving up the plane, so the friction is going to be down the plane, and it's going to be maximum friction. Whenever the object is in motion, friction is also going to be maximum. So let's resolve any other force. No, the 4 newtons is gone now. So we're going to have, let's draw it properly, 0.3 g cosine theta and 0.3 g sine theta. Now, again, sigma Fy, R is going to equal 0.3 g times 24 over 25. And now, think about it. Here, do I have a resultant force? 100% I have a resultant force because all the forces are acting downwards, right? And the resultant force is going to also be downwards because there is nothing to balance it. So this is a scenario 2. Sorry, scenario where we have sigma F equals ma. We have acceleration here. Why do we have acceleration? Because we have resultant force, right? The forces are unbalanced. They're actually all in one direction. And the direction of the acceleration is always going to be the same as the direction of the resultant. So we're going to accelerate downwards. So if we're moving upwards and acceleration is downwards, it means that we're slowing down. And this makes sense. So now for sigma f of x direction is going to equal mass times acceleration. So which direction should I take positive here? If you told me up the plane, I'll tell you you're wrong. Since acceleration is down the plane is going to be the positive direction. So any force that's pointing down is positive. So mu, which is 3 over 4 times r, which is 0.3 times 10 is 3 times 24 over 25. That is mu r, and then plus, because this is also down the plane, 3, and then sine 20 is 7 over 25. This is the sigma f. It should equal m, which is 0.3 times the new acceleration, which I want to find. To find this acceleration, I'm going to divide both sides by 0.3. Putting everything on the calculator, it will give me an acceleration of, so the acceleration value is going to be 10 meters per second squared down the slope. So this is the acceleration now after the force is removed. So while the force was applied, we moved 15 meters and we reached to a velocity of 10 meters per second, and we were moving with an acceleration of 10 over 3 meters per second squared. After the object is removed, now there is an acceleration down the slope 10 meters per second squared. So I want to know how long is it gonna keep moving with until it reaches a velocity of 0 or instantaneous stop. So let's use kinematics again. Let's take up the slope as positive. So I know that my u, my initial velocity, is going to be what? It's going to be the final velocity from last time, because that's my initial velocity now. It's going to be positive because I'm moving up. Acceleration is pointing downwards, so kinematics wise, yeah, did I say I'm going to take downwards as positive? No, I'm going to take, oh yeah. I said I'm going to take up as positive, okay? So acceleration is down, so it's going to be negative 10 meter per second squared. I want to see when velocity, final velocity reaches 0, and I want the distance is going to take for it to reach 0. So which letter didn't I mention? T, so I'm going to use v squared equals u squared plus 2as. So 0 squared equals u squared, which is 10 squared, plus 2 times acceleration, which is negative 10, times s, which I don't know. So moving, this is 100, moving into the other side, negative 100 equals negative 20s. Divide both by negative 20. I'm going to have s as 5 meters. So s moved 15 meters while it was accelerating upwards. And then when the force is removed, it continued for another 5 meters. So the total distance is going to equal 20 meters, and this is how to solve this question. This is very, very common when you combine kinematics with dynamics. This comes a lot. I hope this was helpful. I hope this gave you an insight, and it's a quick revision for Edexcel. Please, if you have a certain topic, because I'm gonna be doing these videos for the next couple of days, as you know, the exam is soon. If you have a certain topic you want me to revise, like what I did here, start with theory, tell you what you should know, and then start on just spamming and solving questions. Please comment the videos down below. I'm gonna read all the comments. Please check the previous videos, check the course. It's very, very, very important, very useful. And if you don't have any questions, just feel free to like and subscribe and comment for any suggestions. And thank you so much for watching.